our question was for number 1. So the figure to the right shows a cross-sectional view of a solenoid with radius of 4 centimeters and 10 to the 5 turns per meter. The current flows in the direction shown, which is clockwise, and where the current is measured in amps and the time is measured in seconds. A coil of wire made of 200 turns of wire in the shape of a square with side length of 2 centimeters is held inside the solenoid as shown over here. So what is given in this question is the radius of solenoid, which is 4 centimeters and it's represented as R, the turns per meter, which is represented as N, and here is the equation for it, the direction of current, which is clockwise as mentioned, and then the current of the solenoid given time, which is here, and Aziz will explain it later, the coil of wire made of 200 turns that is square shaped with side length equal to 2 centimeters, and also the number of loops, which is represented by M, which equals 200.
And for part A, we are asked to find at time 0 what is the magnitude of the voltage induced in the square coil. We are given the formula for EMF, which is equal to negative M delta flux by delta time, where flux is equal to the magnitude of the magnetic field times the cross-sectional area times cosine theta, which in this case cosine theta is going to be equal to 1, so we're going to have BA, where the magnetic field is equal to mu naught number of loops into the current. Using these bits of information, we plug them into the original equation for EMF. Then using substitution for the I here using the formula above, where the current itself is given by 5 into 1 minus e to the negative t over 4. Plugging that in and then finding the derivative of that whole function will give you this equation here, which is negative mu naught into the number of loops of the square wire into the number of turns per meter times the cross-sectional area into the derivative here, which is going to be 5 over 4 e to the negative t over 4. Plugging in the values we were given, substituting for the mu naught, using 4 pi times 10 to the negative 7, 200 for m, and 10 to the 5 for n, and 4 times 10 to the negative 4 for the cross-sectional area. And substituting 0 for t, we're given, or the e will go to a 1 since it's raised to the power of 0. So we have 5 over 4 giving us the value of 0.0126 volts. And for part B, we are asked about at time 0, what is the direction of the induced current in the square coil. Since we have a clockwise motion or a clockwise current in the outer wire, we have a magnetic field pointing inwards or into the page as seen here, and basically there should be a magnetic field coming outside of the solenoid in order to oppose this magnetic field, and that causes the induced current to go counterclockwise.
So basically this was our equation. We explained the given, the solution for part A and part B, and that's it basically.